Let's use the geometry network. I'll call it sim and I'll change the color here. We'll start by bringing in the geometry. So I'm using a file node and I'll bring in the statue geometry that I have got from 3dscans.com. So let's wait for it to load. And I think here's the geometry and it is too big for our simulation. So I'll use a transform node to make sure that the scale is small. But before that, I'm using a convert node here just to make sure that all the geometry is polygon here. Okay, and after that I'm using a transform node, and I'll reduce the size to 0.01. I think that should do the trick. If I zoom in here, I think we will get our geometry, and this is that. The only thing is, I think we should use the references to make sure that the size is correct. And if I template this, okay, you can see that the statue is still too big. So I'll decrease the size of the statue to maybe 0.001 and okay, maybe increase it to 0.00125 and this is good. Okay, I'll rotate it in the Y direction by 180 degrees so that the head is in the positive Y direction, and I'll rotate it in the Y axis maybe minus 90 just to make sure that the statue is facing us directly, something like this. Yeah, and I'll move it up. I want the statue's leg to be sitting on top of the grid. Imagine that grid as a ground plane, so just make sure that the legs are sitting on top of that. Okay, so let's move it up, maybe 1.38. Okay, so this is looking nice. Let me just align this, and what we can do now is I'm going to use a polyreduce node, because if you come close to this geometry, you will see that it is quite dense. There are a lot of points here, and we do not need as much point on this statue because that will be just a waste of memory. So I'll be using a polyreduce node, and I'll reduce the geometry to only 10% of what it is actually. So there are 1 million points, and 10% of that 1 million would be almost 100,000. So I'm keeping only 10% of the geometry. Okay. So now you can see this is a lot less dense, and if I check, you can see there are 100,000 points, which is 10% of 1 million. And I'm using an attribute delete node just to make sure that there are no attributes on the geometry when we are doing the particle simulation. Okay, because I do not want any unnecessary attributes here. I'll also untemplate this because we do not need that. This is our main geometry that will be where we will be scattering points, or we will be doing the particle simulation. Okay, so what I'm going to do is, let's use a pop network. Pop network is the DOP network where we create particle simulation, and you can see the statue. This is the guide which is representing that statue, and if I play this simulation, you can see that all these particles are being generated or being emitted on the surface of this statue that we had connected here. Okay, and that is happening because in this source node, this is the source node where particles are being sourced, we have emission type scattered onto geometry. So the particles are being scattered onto the geometry. Okay, and we have connected the first input, and the first input here is our statue. So that is that. We also have here a group where we can specify which part or which group of the geometry we want to emit particles from, and we have attributes also where we can which we can use to emit particles. Okay, so let's create a group here outside, and I'll call it emit, and I'll turn this off, and I'll turn on the keep in bounding region, and I'll just create a group here. Okay, so let me just select the group node, this, and now we can select a area which is going to be in this group, and let's just select the head. Okay, so this head, all these particles are now in our emit, and if I go to the source node and if I choose source group is going to be emit, the particles are going to be emitted on that group. Okay, and that group consists of the head area. So all the particles are being scattered or are being emitted on the head of the statue. As you can see, if I template this, all the particles are only being emitted on the head area, and that is actually quite good. We can use this for a lot of things, and that is how you use the group method. Let me just create a pop force here just to make sure what happens when we apply some forces here on the particles. So the particles will be generated on the head, and if we play this, you can see that the head is emitting the particles. And because of the force, pop force, we have applied some forces here, and that is why the particles are behaving like this. They are flowing in like this. So if I choose the force and if I increase the force in the positive x direction by 1, you can see that the particles are being scattered like this, and they are flowing in the positive x direction because the force is in the positive x direction. So that was pop force, and that was how you use the group here. We'll see everything else later. And now let's move on to other tab, which here is the birth tab, and here we have impulse activation, impulse count, constant activation, constant birth rate. Let's first bring the constant birth rate and constant activation to 0, and we are keeping the impulse count to 1. Now when you run the simulation, you can see that particles are being generated, but what this impulse count does is it defines how many particles can be generated per frame. Okay, so when the impulse count is 1, that means we are saying to the simulation that only 1 point per frame can be generated. So on 24 frame, 24 points, and at 25 frames we are generating 25 points. And if I increase the number of point at the impulse count to 2, then you can see that at frame 25 the number of points will be generated will be 50. Okay, so that is that. Now if we turn on the constant activation, and if I keep the constant birth rate to 100, you can see the simulation is emitting a lot more particles. Okay, so the constant birth activation defines how many particles can be generated per second, not per frame, per second. Okay, so at 24 frames it should be generating 100 points because we have defined 100 points here. 100 points, okay, and 100 points, 101 points. So almost there. So constant birth rate controls how many points can be generated per second, and impulse count defines how many points can be generated per frame. Okay, so just keep in mind, remember this, that impulse count and constant birth rate are two different settings. And if you want to define how many particles can be generated per frame, then you should be using impulse count. Okay, and if you want to define how many particles can be generated per second, then you should be using constant birth rate. Okay, so I think that was important. And now if you want to set a limit on how many points per frame can be generated, then you can come here, maximum point per frame, and if I set it to 1, you will see that the points are being scattered, but only 1 point per frame will be scattered. So if I see here, you can see that 24 points are being scattered on 24 frames because I set the settings here 1. If I revert to default, you can see there are almost 100 million points that can be generated per frame. That is the limit. So you can play with those limits as well. And now we will come to life expectancy and life variance. So what this life expectancy and life variance does is it generates an attribute called life attribute. Okay, as soon as the particle is born. So here is the life attribute, and what this life attribute defines is that how long a particle is going to live. Okay, so if I set the life expectancy to 100, that defines that a particle will be living for almost 100 seconds, not frames, 100 seconds. So if I turn this on, and you can see the point number, you can see that all these points, they will keep on flowing because their life expectancy is 100 seconds. If I move this ahead, you can see that they are not dying. They will just keep moving forward because they will keep moving forward for as long as 100 seconds. So if I change the life expectancy to 1, Now if I run the simulation, you will see that the life expectancy is reduced to 1, that is 1 second, that is 24 frames, and after 24 frames each particle is dying. Even though we are birthing new particles every frame or every 24 seconds, each particle will only live for 24 frames or 1 second. Okay? I hope you understand this. And you can see that each particle has a point number here. And this point number is very unusual in pop, because if a particle has a point number when we are generating it, that point number is not unique to it. Okay, so in pop simulation, if a particle has a point number and if that particle dies, then that point number can also be assigned to other particles. Okay, so in pop network, point number keeps changing for the particles. Okay, it is not permanent, and it can definitely be assigned to other particles when one particle dies. So if a particle has a point number of 1 and that particle dies, then that point number will be assigned to other particle. Okay, if you want some unique identification, a unique ID for these particles, we have a attribute called ID attribute. Okay, and what these ID attribute does, let me just turn on the ID attribute. I think we'll have to go outside on the geometry network level. And now if I visualize the ID attribute, here's the ID attribute, and I'll just make sure that this is a marker to visualize. Yeah, so now you can see each particle has a ID attribute like this. So we have a particle somewhere here which has ID attribute of 1. Yeah, so this is the 1, and just keep on looking at the particle with the ID attribute, this one, which has ID attribute of 1, and at some point of time it is going to die. So this has vanished. At frame 25, that particle has gone, but the ID attribute is gone with it. Okay, that ID attribute is retired now. It will not be assigned to any other particle. So this has ID attribute 1, and on frame 25 it dies, and that ID attribute is retired with that particle. That will never be used again. Okay, that is not true with with point number here. Okay, so what is that? I wrote something here. Where did it go? Oh, okay, it is here. I'll just copy this and cut it and paste it here. Okay, so it's not happening. I don't think I can paste notes, so I'll just Control Z. So we have this. I'll copy this, move this. Okay, so I did not know that we couldn't do that. So yeah, cannot paste it. Let me just copy all the words here. I'll delete this, create another node here, and I'll paste the words. Okay, so in pop network, a point number keeps changing for the particles. It is permanent. It is not permanent. It can be assigned to different particles. But when we create a particle, it is assigned an ID attribute, and that ID attribute is permanent or unique to it, and it will be retired when the particle dies. Okay, so when we create particles, ID attribute is unique and permanent and cannot be assigned to other particles, to multiple particles. So I hope you understand that now. So if we have a closer look, just one last time. If I come back here on frame, I'll turn this off. Okay, so this is our point with the ID attribute 1, and when it dies, at frame 24 it will go away, it will die, and that ID attribute will also be retired with it. But the point number is not retired. Point number is assigned to something else, some other particle. Okay, so I hope you understand this. Here we have point number, and on frame 25 it dies, and that point number is assigned to other point number, other particle. Okay, so let's move on to our next tab, or the next setting that we will cover in our pop network, and I think that is life variance. So we'll come to our source, and you can see below life expectancy, life expectancy, we have life variance. Okay, so if I set the life expectancy to 2, and if I set the life variance to 1, I'll bring it to, actually I'll just set the life variance to 0 for this. And when we run this simulation, you know that the particles are going to live for 2 seconds, started 48 frames. So if I go to geometry spreadsheet, and if I go to geometry, you can see we have all the particles, we have all the attributes which are on the particles, and we are looking for life attribute. So I'll search for life attribute, and you can see we have an attribute called life, and the value here for all the particles is 2. Okay, so all the particles here have a life expectancy of 2 seconds, that is 48 frames. Okay, what if we need some randomization there? What if we want each particle to have a different life value? So we are going to use life variance for that. So if I change the life variance value to 0.75, what it actually does is it will give a random life attribute value to all the particles, and that value is going to be between life expectancy plus minus life variance. So what I mean by that? So what do I mean by that? Okay, so if we have a life expectancy of 2, and if we have a life variance of 0.75, the random value that each particle, the random life attribute value that each particle will have, will be between 2 plus 0.75 and 2 minus 0.75. Okay, so 2 plus 0.75 is 2.75, and 2 minus 0.75 is 1.25. Okay, so the random life attribute value for the particles will be between 1.25 and 2.75. Okay, that's what the life variance is doing. It is helping us in providing each particle with a different random life expectancy or life attribute value. Okay, and each particle will have a different life attribute value, which will be between 1.25 to 2.75. Okay, and that's what the life variance and life expectancy do. So if we go to the attributes, we will use all of this in the later tutorials when we go deeper into pop network. But for now, I think these are the basics that we are going to need for this tutorial, and some of the basics that we will need for the next tutorials. Okay, so I think these are the basics. So let's move on to our proper project now, our proper tutorial that we need to cover. So I'll just turn off the group here, and what I'm going to do is I'll use a attribute adjust float node. Okay, because I want to create a mask attribute on this statue. And the one thing that I did not show you was how to use an attribute to emit particles. Okay, so that's what I'm doing here. This is all correct. I'll just visualize this mask attribute that we have created. Okay, so I'll just visualize this, and now you can see that we have a mask attribute on this statue. Let me just grayscale it so that we have an understanding of where the values are positive and where the value is 0. So this is our geometry, and you can see the black areas are the areas which has a mask value of 0, and white areas has a mask value of 1. Okay, and if I sharpen the ramp, this is how it is going to look. And if I come to source here, I'll just remove this group and I'll use a mask here. Okay, so the particles are going to be emitted only from the areas which has a mask value of greater than 0. Okay, that's why I have assigned a emission attribute here. And if I turn this on, scale point count by area, then you can see if I just bring it to maybe 1, you can see that we will have more particles here. And if I change the constant birth rate to its default 5000, now when we play this, you can see that all the particles that are being emitted are being emitted from the areas which has a mask attribute which is greater than 0. Okay, so that's how we are using our emission attribute. If I turn this off, and if I remove the mask, and if I play this, you will see that the particles are being emitted from the whole geometry. We have not specified any area where we want the particles to emit from. So it is emitting from everywhere. That is what you need sometimes, and sometimes you need to define where you want the particles to be emitted from. So everything is okay, you can choose whatever you want. Let me just re-choose the emission attribute, reassign the emission attribute as mask, and I'm turning on the scale point count by area, and you can see that it is the particles are only being emitted from the areas which has a mask value of greater than 0. Let me increase the constant birth rate to 50,000, which means we are generating 50,000 particles per second. So as you can see, the amount of particles has increased drastically, and I think that is nice. If I change the force to 0, and now when we run this, I just change the force value to 0 in the pop force, and this is the result that we are getting. You can see only the areas which has a mask value of greater than 0 are emitting the particles. So we have two options here to emit. One is mask attribute, one is some kind of attribute, and one is group. So in the attribute adjust float, I am decreasing the element size to something like this. And now when we play this, you can see it is also animated. So see, the mask attribute is being animated on the geometry, and because it is animated, the emission areas are constantly being changed. Okay, so as you can see, the mask attribute is animated, it is changing, and because the mask attribute is animated, our emission source or emission area is also changing constantly. I've changed the constant birth rate to 3000 because I wanted to see the effect, and now you can see the effect that the emission areas are changing constantly. Okay, it is not emitting from the same place. The emission areas are changing, and that's what we wanted. So imagine if we can control through attribute which areas are going to be emitting the particles and how many particles are going to be emitted, and what is the life expectancy or life variance is going to be, then how much control we have over the simulation. Okay, and that's what this groups and attribute emission are there for, because they're going to give us control of our simulation. So now we can move ahead with our final tutorial. So this was the final example. I think that's what you needed to learn as a basic. And let me just turn this off. And now I think I'll just okay, so let me just reset the viewport, and I'll just align this and move it here. And now we want to create a mask attribute which will be going from the right to the left of this geometry. Okay, as you can see in the preview, we are scattering we are emitting points from right to left. Okay, so how can we do that? We need to create a mask attribute again here. So let's create a vector called mask, and this is going to be equal to the function called relative point b box. Okay, this is a function called relative point b box, and it is running on the geometry input 1, and it is running with respect to position attribute. Okay, so what this is doing is it is giving each point of this geometry with a relative value with respect to the bounding box and with respect to its position. Okay, so let me create a float called mask x, and this is going to be equal to the x variable of the mask vector that we created earlier. Okay, so float called mask x is going to be equal to mask.x. You can name them whatever you want if you're getting confused, but I just use this, so don't worry about it. So float called mask x is equal to the z value or the z variable of the mask vector. Okay, and then just to visualize this, we are creating a mask attribute, and it is equal to mask x. Okay, so if I visualize the mask attribute, you can see the values are going from 1 to 0 from right to left. Okay, so the points which are present in the right side have a value of 1, and the points which are present on the left side of this geometry has a value closer to 0. Okay, now I want to add a offset here, so I'm creating I'm writing mask x plus equals, I'm creating a channel float called offset. Okay, let me just press this button to create the offset. And now when the offset value is 0, which means we are adding nothing, then the mask remains same. But when we add 1, then you can see here, let me just turn on the mask. And if I turn on the mask, and if I change the values to marker, you can see that the points which are on the right side has a value which is closer to 1. Okay, so all these points here have a value of which is closer to 1. Okay, and as we move towards left, this is 1, closer to 1, as you can see. And if we move closer to left, as we move left, the values are going to keep decreasing, and it is interesting that the values will keep decreasing and they will keep moving towards 0. Okay, they will be closer to 0. So the values are running from 1 to 0 from right to left. As you can see, if we can go at the utmost edge here, you will find that there's a point which has a value of 0. As you can see, this point has a value of 0. Let me just close this. And there must be a point on the right side which has a value of 1. So on this geometry, the mask value is running from 1 to 0 from right to left. And let me just make this RAM from attribute so that we can visualize it by color. From white to black, from right to left. And when I add the offset 1, you can see, if I make this marker again, you can see I have added an offset value of 1, and the values were going from 1 to 0. So now the points which were closer to 1 are closer to 2, because each point and each of its value has been added by 1, and the points which were closer to 0 are now 1. Okay, the point which were 1 becomes 2, and the point which was 0 becomes 1. As you can see, 0. So this point is 0. When I increase the offset, it becomes 1. So the values are now change this to visualize this as color. You can see the values are going from 0 to 1, and when I add 1, the values now are going to 1 to 2. Okay, now if I come to edit parameter interface and make some changes in the range of this offset from -1 to 1, it was going from 0 to 1, now -1 to 1. And if I now change the value to -1, you can see everything is black. Okay, because the values are going from -1 to 0. Bring it back to 1, the values are going from 1 to 2. And as you can see, we are having this effect, this beautiful effect of mask. Okay. So if I change this and you can see it as marker, these values are now closer to 0. Okay. So we have our 0 here. And if I add 1, this becomes 2. And if I keep it at 0, this is 1. Okay. So this point value is going from 0 to 1. And if I make it 1, then it is 2. The values now are ranging from -1 to 2. That's what I'm trying to say basically. Okay. When the offset is 1, the values are going from 0 to 2. And when the offset is -1, the values are going from -1 to 0. So because the total package is going from -1 to 2, we can clamp these values. Okay. So mask x is equal to clamp mask x from 0 to 1. So any value that is below 0 will be 0 and any value that is above 1 will be 1. So now you can see that we have this mask effect which is going from right to left. This is 0, this is 1. Okay. Now if I visualize it as a marker, you will see that all the points have a value between 0 and 1. Okay, all the points have a maximum value of 1, and when the offset is at -1, all the points have a value of 0, and you can change the values like this. Okay, so we have this mask running around like this, which is going from left to right, and that's what we wanted. Something like this, 0, 1. All the points have a value of 0, and when we increase, all the points have a value of 1. Let me visualize it as a color, ramp from attribute. So this is important, that's why I'm taking time here. This is the mask that is going from 0 to 1, and with the help of this, we are going to create a mask which will be used finally in our pop network. So we can animate this now. Okay, this offset value, we can animate this. So on frame 1, I will just keep let me just move it here to -1, and on frame 1 the offset value is going to be -1. Okay, and at around frame 130, somewhere here, 150, I just keep the frame range from 1 to 150, and at frame 150 the offset value is going to be 1. So this is how the mask will turn out when we play the animation. Okay, something like this. The value on for all the points, the mask value for all the points is going to be 0, and at frame 150 the mask value will increase to 1. Now when I connect this geometry to our pop network, and in the source the attribute emission is set to mask, and now when I run this, you can see as the points get a mask value of 1, they will start emitting. Okay, so let's run this pop network. No emission, and suddenly as the geometry start getting the mask value of 1, they start emitting. The geometry start emitting. No emission initially, and then as the mask value increases along the body, along the geometry, emission starts. Something like this, from right to left, and that's what we wanted. So it's looking nice actually. Let's run this, and you can see from right to left the emission of the particles is happening. From right to left, something like this. What we can do is, I want to create something even better here. Okay, what I want is, I do not want this geometry to have a final, for all the geometry points here, for all these geometry here, to have a final value, mask value of 1. I want the final mask value to be 0. Okay, for initial brief period, I want the geometry to emit, and after that, I do not want any emission on the geometry, from the geometry. So that's why I'm creating a mask here, and we will remap this. Okay, so we will remap this in such a way that initially the mesh will have a mask value of 0, then the mesh will have a mask value of 1, and then the mask value will go down to 0. So I'm creating some points here. I have 4 points, and the first and last point will be 0. Okay, so now, as you can see, if I run this is what we are getting. Initially, the mask value is 0, then the mask value is 1, and then it becomes 0 again. It is going through the body, going through this mesh. Okay, so this is our remap curve, and if we go inside of our pop network, you can see this is what we are getting, which is pretty similar to what I used in our preview. I'll just increase the constant birth rate to 10,000 so that we have more particles emitting. And as you can see, the emission starts from right to left, and then the emission stops also. No emission starts from right, then it goes towards left, and then the emission stops from the right and it fades away completely. And that's what we want. Something like this. So our geometry initially had a mask value of 0, then geometry gets some mask value which is 1, and then it fades back, the mask value fades back to 0. Okay. Now if I make it a little sharp, something like this, I'll move this point here so that the mask attribute value, the mask on the geometry is for a very little time. That's what I want. I do not want it to linger for more than we need it to. So I'm just playing with this point values here, and I'll bring it closer, bring this one closer, somewhere here, move it up, something like this, and I'll bring this point somewhere here, somewhere here, and now when we run this, the mask attribute, let's see what we are getting. Let's run this, and you can see that the emission happens for a very brief period of time. Okay, the emission starts and then it fades away because the mask attributes fades away, and this is what we want. So this is looking very interesting, and if I just come here, and if you can see the mask attribute, initially no mask attribute, and we are getting this line where the mask attribute is 1, and then it fades away to 0. 0 mask attribute, 1 mask attribute that goes along the geometry, something like this, and then it fades away, fades back to black.